going to talk about today is its regional growth theories. It's basically like GDP and productivity growth. When is it coming from, and how can it be influenced? We'll talk about it's going to be like mostly not about regions, but more about countries. But we'll touch on the regional aspects of it as well as what kind of function cities and urbanization in general play in it. We'll also, like at the end of the lectures, we'll talk about something which is called Malthusian trap. I don't know if you know the concept from macroeconomics. Anyway, we'll basically look into what's happening like all around the world and with like demographics and how they influence the productivity growth. So let's get to it. First, we'll have to start with somehow dry theory. So bear with me before we get to something interesting. You kind of like have to hear about this, kind of like understand the formalization of the process. So again, in macro, you probably heard about something Cobb-Douglas function, a production function, which is basically what you see over here. Again, can you just quickly confirm that you see my mouse moving on the screen?
Yes.
Perfect. Thank you very much. So this is basically what the Cobb-Douglas function is, and basically it shows a few factors coming to a GDP growth. So Q at time t, it's basically the product, equals A times K alpha times L beta. So the K stands for capital, L stands for labor. So K is basically the amount of infrastructure, the factories, everything which is tangible in the economy. Sometimes you can also like say like there's something like a human capital, so it can be part of it as well. L is the quantity of workers which you have. This model is really simplistic. It's almost stupid as simplistic it is. So it basically expects that all the workers in the economy are the same. And the only thing which we didn't mention here is the A, which you probably already know stands for technology. It's basically how we do stuff. We use this Cobb-Douglas function because it has some nice mathematical properties and kind of like make the math work. But like you should understand it is a major simplification of what it is. For example, it exhibits the constant returns to scale. For most of what you heard in the macro and micro classes, constant returns to scales don't really exist. What you usually see is diminishing returns to scales. Basically, the more of you add of one factor, that means that there's less bang coming out of it, right? So if you just like keep adding capitals, for example, you don't expect that the capital will that the product will grow at the same speed. Anyway, this function kind of expects that. So basically, what it says, you for example double the capital. So what happens with the product? What happens with the product? It grows at some speed, probably not double because this alpha is usually less than 1. So it will, let's say, if this is halved, it will grow by 50%. And then if you double the capital again, this part, the product on the other side of the equation grows by another 50%, and it keeps going on. If you just keep doubling the K, this thing just grows at a constant rate. So that's the constant return to scales. The scale, it's one of the properties of it. And let's get on. Basically, the production function, which which might kind of look kind of strangely as a formula. If you basically just look at it, what it means, it basically means that you have factors of production. Usually, the production function just looks at the capital and labor. And then there's a transformation of inputs, which is basically how we make something out of something. And then there's output. That's basically what it means. That means you have people going to factories, some materials coming to the factories, something is being made, the output is being created and sold for amount of money. So that's basically the GDP which you hear at the end. The Cobb-Douglas production function kind of neglects the L, the land as a production function, because like the classical economic theory, they basically expect land to stay constant, which is again a huge simplification. it's true that it's constant, but like the way how we use land is hugely variable. But in the production function, you usually don't hear about land as a production factor. So we're going to ignore it for now as well. But you should know it, like it actually matters a lot. Actually, how land is used, especially in modern economy, where like most of the production is happening in cities. Most of GDP nowadays in any modern economy is services, and that's happening in cities. And it basically means that the way how you build a city kind of influences the GDP in a major way. So this land as a production factor matters a lot, but the classical economy kind of ignores that factor. So we're just going to ignore it for now as well. To finish what the Cobless-Douglas function does, we can kind of change it. Before we had alpha and beta, now we have alpha and 1 minus alpha, basically saying that what capital contributes, and what doesn't contribute capital contributes the alpha. So like basically altogether they are one. The only thing which I'm going to add to this now is so basically, if I take the Cobless-Douglas function and I differentiate it in respect of time, I'll basically get to the change of product, which is the GDP growth. And basically, this function kind of like becomes this one, and basically it says I add capital, the impact of the capital, I add labor, impact of the labor, change of the technology changes into some kind of a constant, and bang, this is the GDP growth. So now I want to speak a little bit about the biggest prize in economics, which is the technology. The A, which is here in this function. That means how we do stuff, because if you look at how the economies differ one from another, how do you what is actually the reason why some countries are rich and some of them are poor? Obviously, there are differences in people, there are differences in how much capital you accumulate, but the biggest difference almost always is what kind of technology you are actually using. Also, with peer, you heard, again, probably in macroeconomics, you heard that there were periods of time when the economy grew really fast. There were periods of time when the economy didn't really grow so much, and almost always you can find that the reason for this is kind of coming from because there was some kind of like a dramatic technological change which basically made everything easier to make, more productive, and that's still kind of the thing. Just like to mention like the major technological improvements in the past. Obviously, into the late 1800s and early 1900s. Basically the biggest innovation at the time was electricity, running water, and you can kind of easily see that had a huge transformative impact. And because of that, these periods of times, like 1870s till 1930s, were basically like one of the strongest periods of GDP growth in developed countries. Mostly it kind of came a little bit later to developing countries. And the same thing, even earlier than that, the Industrial Revolution basically did the same thing. Suddenly, you didn't have to use horsepower, you could use engines. And more recently, in the 90s, the computerization of office work, basically, the computers which replaced the typewriters, basically made a lot of jobs redundant, and of course that labor could have been used somewhere else, which increased the overall productivity. So basically anytime there is a period of really fast GDP growth, it's always coming from some kind of a sudden technological progress. And now, what do you, as an economist, what do you do with this information? you basically just wait for another technological innovation to kind of happen, because the rest is kind of difficult to pinpoint. Of course, that's not technology is not the only reason. Like institutional quality has an impact, the stability of the economy, how much capital you actually accumulate, how educated is your workforce. That all matters. But the technology is the big prize. That's basically which the thing which makes everything moving a little bit faster than before. And obviously, this technological change, it kind of comes in stages, but also it takes a while before it actually kind of like it comes, it gets adopted in in the workforce and in the whole society. So and that's something which we called, and this is an important term, technology diffusion. Basically, I have here a few, basically just a slide which explains what the technology diffusion actually is. Basically, the new technology is introduced, and it takes a while before people and workers and businesses start adopting it. And originally it goes a little bit slower, then then there's a really fast adoption, and at the end it slows again. Again, neoclassical theory basically looks at it a little bit simplistically. It basically expects the diffusion of technology to be instantaneous. But it just simply doesn't work that way. Usually the diffusion of technology, tends to exhibit the S-shaped form, which is basically what you see here on this chart. So this is a chart which shows a number of innovations as they were introduced in this case in the United States. And basically they show how long it took, how many years before that technology was adopted by percentage of ownership, basically how many people not always ownership. For example, in the case of airplanes, how many people were using that innovation. So for airplanes, for example, it took about 60 years before even 10% of people start using airplanes. With cars, it was much lower, much longer growth. But you can see that it took about, again, almost 40 years before even 10% of people start using car. And you can also see that the newer innovations, they basically started to be, they were started to be adopted a little bit faster than all the other ones. So electricity was faster, but then microwave, radio, TV, internet, cell phones. This chart is a little bit outdated, so cell phones here shows only 30% of adoption, but of course, that's now close to 100%. It's always like this, like L-shaped. Originally nothing much is happening. Then there's a fast adoption, and then the laggards, basically the last people kind of they are always resisting the adoption of the technology a little bit. What is important here is that you can see that these curves, the technology diffusion is obviously getting simpler now. So basically, every time there is a new invention, people adopt it faster than they used to. And I will get to the next point. It also happens globally, not only in certain certain population. It also happens that globally, technologies are basically for example, after they are invented in Sweden, in the United States, in Israel, that majority of the world adopts them nowadays much faster than they used to. The same thing goes, this chart basically shows the same thing as the first one. How many again for the United States, after how many years after invention of selected technology, did it reach 80% of country coverage, basically getting to somewhere at this point before it slows down again. So for railways, it was 125 years, for telephones 100 years, for radio 50 years, for personal computers 25 years, for mobile phones it took about 18 years only, and it's getting faster and faster. You can also say that these inventions are actually less capital demanding, and that is definitely true. But for example, if you compare telephones 100 years, and internet use, which also requires basically the same amount of cabling, maybe more, it took only 25 years, a little bit less than 25 years. So this shape, is basically becoming steeper, and basically means that technology is spreading out faster than it used to, and it's a good news. It basically means that the benefits of technology and its impact on GDP growth are basically like being reaped faster than they used to be. And now to the spread of the technology around the world. So this chart, it might be a little bit confusing, so I'll try to explain it a little bit better. Basically, it shows you the difference. There's 5 major regions in the world. USA, Great Britain, Japan, Asian tigers, and sub-Saharan Africa. And for each of these inventions, so this is steam and motor ships, electricity, innovation, internet, it shows you how far in advance or how far behind these regions were to adopt the given technology. So for example, and 0 is always average. So for example, for motor ships, it took, if like the first country which adopted was United States, minus 90 years, and the last one was Asian tigers, plus 55 years. So basically 140 years it took before it was introduced between United States and Asian tigers. For electricity, you can see, 100 years later, motor ships came in 1788, electricity in 1882. You can see that this difference between the first region, which in this case was Great Britain, and in the last one was Sub-Saharan Africa, you can see that suddenly it's only about 55 years. So 140 years, 55 years, for only 55 years over here. For aviation, which came again a little bit later, the difference is still substantial. And then, for various inventions, you get to internet, and took only about 5 years, when it was introduced in the United States, and took only about 5 years before it was introduced absolutely everywhere, in all regions of the world. And this shape of this curve, basically how they are getting closer, it basically shows you how technology spreads around the world much faster than it did before. Of course, some of the inventions were telecommunication inventions. Internet is a big thing now. So nowadays, when something is invented, basically all of the countries around the world basically get the introduction of the technology almost immediately, because they are in constant communication. Last bit about theory, which I'm going to mention, is that there's something called a Romer's model, which basically takes the, it basically corrects the the Cobb-Douglas function when they say there's 2 production factors. It's kind of simplistic. So the Romer's model basically extends the Cobb-Douglas function using knowledge as a factor of production as well, and it basically differentiates between 2 kinds of knowledges: company-specific knowledge and universally available knowledge. I'm not going to spend any more on that. I just want you to know that there is a ways how to extend the original production function, which is way too simplistic, by using other factors, and I'm going to go on. So most of the growth which we see now is not a growth. It's not a growth at the technology frontier, but it's a catch-up growth. Basically, the global growth of GDP was something about 3%, 3.5% in recent years. It was a little bit less than it used to be. The world now doesn't grow as fast as it did only about 10 years ago or 20 years ago. And most of the GDP growth which we see in the world is basically coming from places like China, India, Indonesia, Vietnam, while the developed countries, they are actually not growing so fast. And why do countries like China, India actually grow so much? One of the hypotheses is that they basically export a lot to developed countries, to rich countries, but that hypothesis actually, at least for last 10 years, doesn't really stand so much, because the world trade actually stagnates. If anything, there wasn't really any growth in world trade in recent 10 years. But China and India, they are still growing at about 6% a year. In India's case, it's a little bit more volatile. One year it's 7-8%, 1 year it's 3%. In the case of China, it's roughly almost all the time it's 6%. But there's a wide discussion about how reliable Chinese statistics actually are. So basically, if you look at the current GDP growth, that means pre-COVID-19 GDP growth, right now everything is kind of in the air of what's going to happen. But in the last 10 years, China and India and all of the other developing countries, they basically kept growing as fast as almost as fast as before. Their contribution to world GDP growth is still larger and larger as the economies grow. But there is not the argument that it is the world trade which actually causes it, globalization in general, doesn't actually stand so well, and the major reason why they are still growing so fast is because they are basically catching up on the technology change. Basically, they are not only building capital, but they are basically adopting the production processes which are available in the developed world, and they basically just start using it. Basically they are building all the infrastructures which are connected to technology. They are building the like fast transmission networks for electricity and for internet, and so basically this is still going on. And what we see now is basically this catch-up growth in developing countries, which is caused mostly by by just these countries adopting these technologies which already exist somewhere else. And well, I just want to kind of like take it back to the regional economics a little bit. Effective cities are the key gateways. Basically, like majority of the communication of the diffusion of technology between countries basically happens through universities and through businesses which are located in cities. You can find out that people in Beijing in China adopted like internet much faster than majority of villages in anywhere in developed world. There's still quite a lot of places in the United States or in Europe, in villages where there's no internet coverage, while major cities all around the world, including Nigeria, including India, everywhere, they already have internet, for example. So basically cities are always the place where the technology gets adopted the fastest. And from there, it basically kind of trickles down to the rest of the country where it was introduced. A little bit more about the technology diffusion. Like right now, the biggest question not right now, but basically all the time, the biggest question of in economics is, where is the next big GDP growing technology innovation going to come from? And it is a big question because like right now, the developed rich world is growing really fast, mostly because there is not really so much of technological progress. Since the computerization of office spaces, there was quite a few of innovations, internet for one of them, but it actually didn't cost so much it didn't really change much in a GDP. Like the productivity growth really, if anything, just slowed down, and there wasn't anything which we can think of as like a boost given by internet. And that's despite the fact that nowadays, basically majority of population, we basically reached with internet, we reached the 80% mark now in developing countries. In developed countries, really just a few years back, even Czech Republic now has more than 80% of internet users. And but in GDP, it doesn't really show that much. And the answer why it probably is that internet actually isn't as transformative technology as you would expect it to be, probably. Internet basically doesn't change how we actually make things. It like made many things much simpler. For example, shopping was made much simpler by it, but it actually didn't cause like didn't cause like a doubling of production. For example, if you compare it for example with electricity, electricity basically made producing of everything much cheaper than before, and because of that, the prices went down, people could afford more of it, and just started buying more things. With internet, this transformative potential actually wasn't realized, or like basically never existed. And the question is, where is the next transformative technology actually coming from? And there's a few candidates, of course. Basically every time you're looking at transformative technology, you basically want a technology which destroys jobs, which is kind of counterintuitive point. And you want that because you want to save money, and like mostly you save money on labor costs, and you basically just hope that because you make something cheaper, because less labor is used on it, that the market will create like jobs somewhere else instead. And that has a lot of historical precedents. There's a name for it. It's called creative destruction. It basically means that you save money on jobs somewhere else, and instead of that, somewhere else jobs will pick up again. It's not really easy for some people if you're working in a job for 25 years and your job gets destroyed and you're already late 50s. Obviously, the fact that you might learn how to program doesn't really help you as much. But in long term, it works that way. Every time you destroy jobs because you just find a way how to make something easier and in a simpler and cheaper way, that some other part of the economy basically picks up and jobs gets created there. So like right now, the biggest technologies which have the potential of creating basically saving jobs and making everything cheaper is robotics and artificial intelligence. How much they will actually manage to save is really hard to see, and how will they actually transform the economy and how, the way how we work is also like very, very hard to see right now. Interestingly, it might actually change a lot about the global economy as well, because for example, robotics, if it actually became cheaper again to build stuff or make stuff in the rich countries, just because you just didn't have to use the expensive labor, the whole of global trade would basically stall, because there just wouldn't be any more reason to actually outsource to places like Vietnam or Bangladesh. The problem with this might be that a lot of countries actually got the original boost in growth from exporting themselves to growth. Like originally it was Japan, then like South Korea, then Taiwan, then China, and nowadays most of your clothes is being made in Bangladesh and Vietnam. If robotics kind of replace this whole model of countries basically being outsourced to, that basically means that the next wave of countries which would get richer by international trade wouldn't happen. And it's mostly Africa which people are worried about, because the whole Africa is kind of a laggard in in the GDP numbers, and we'll talk about Africa a little bit later in this lecture. So now really quickly to the point which I was making before about how the cities are basically the effective gateways into countries, and throughout which the technology is actually being passed on. There's like interesting correlation which you can see in this chart, which is basically the correlation between the GDP per capita levels and urbanization levels. The correlation is really strong. One,
Professor, yep. I'm afraid your screen is off. I personally only see your web camera.
Thank you very much. Thank you for telling me. I'm just going to screen it. some reason, it doesn't offer me the option. Sorry, I'll have to restart the lecture because Teams is telling me that it doesn't recognize it. What about now? Do you still see the lecture now?
Yes, it works now.
Perfect. Thank you very much. So basically, this chart shows a correlation between GDP per capita in many countries. All these like dots over here represent the various countries and the urbanization level. Of course, this correlation doesn't say that one causes the another one. And basically, partly it might. The correlation is really strong. The R square is equal to the 75%, which is a really strong correlation, and basically tells you that the more urbanized the country is, the richer it is. Again, the causality.
Sorry, Professor. One more question. Are you seeing the chart right now? Because I see the first screen, the first slide of the presentation, or are you just talking about the chart without?
No. Yeah, you should see this.
Okay.
The chart.
Okay. Yeah. Now it works. Thank you.
Do you see it now?
Yep. Now
you
yes.
see the chart.
I don't know. Maybe my session was lagging, but now I see it. Yeah. Thank you.
Yeah. So, but you all see the chart, right?
Yes.
Okay, cool. So again, the causality between the two things can go like various ways. Basically, it's not really surprising that some countries have a high urbanization levels and high GDP per capita levels, because most of the modern economies and services are mostly in cities. But the fact that that the modern economies are structured in such a way that the innovations are happening in cities, and you need cities to have universities, you need cities to have big businesses which actually create something which is high added value, and all these things are happening in cities. So the urbanization level obviously has a high say into how a country can or is. Now we'll take a little bit of a detour, and I'll show you basically, how GDP was developing over, basically since the beginning of time, or since we can talk about something like a civilization. Of course, at the time. So, for example, this first chart shows you basically the GDP levels from year 1 to 2008. Of course, at year 1, just a year after Christ was born, or since we started measuring time, Christ was born actually about year 4. They calculated it wrong, but at year 1, nobody actually calculated GDP. GDP was invented in 1933 by Samuel Kuznets. But researchers, historians, they basically recalculated GDP all the way back, depending on how good the data actually was. And and this chart basically shows you GDP distribution around the world, in various years for various regions. So, dark purple is China, India is pink, Japan is light blue, and you go on and on and on. And always 100 is the whole world. So you can see that, it never reaches actually the whole 100, because there's many other countries which are not on the list. So in year 1, you can see that China was.
Sorry, Professor, I'm still on urbanization. Are we?
Guys, do you see the chart which has history of the world's GDP?
I'm personally still on urbanization with high correlation.
What about
Yeah.
the rest of you?
Now,
No, yes, it changed now.
yep. Thank you.
I have no idea why is that happening. All right, maybe I just have to click out and in, like, you know, okay. Well, we'll see. You know, I'll just keep telling you that when I'm changing slide, so you can tell me if you actually see the change in a slide, okay? All right, so in year one, you can see that about 25% of the world GDP was China, about almost 40% of world GDP was India, and Italy. You know, it was a highly populated region at the time. Was, well, about 5% of the world's GDP, but the rest of Europe at the time was basically not populated. Like there was like not much happening in them in that. So you can see that around the time, like basically like, you know, more than 50, almost 60% was China and India. And the rest of the world was comparatively really poor. If you look at you know, and then as you go throughout history, basically the same pattern goes on and on and on, and it basically extends all the way till 1820. You know, when the Industrial Revolution finally properly kicked in, and you can see like since then the European countries and the United States a little bit later started growing very rapidly, and to what we like knew in 1970s, that basically majority of the developed of the world's GDP was basically created only by developed countries. What I want you to kind of see is that you know, historically, the fact that rich countries are rich doesn't really, you know, it's a very new thing basically since 1820s, when Industrial Revolution basically changed everything. The reason why it was is that, like, you know, at the time we didn't have much of a diffusion of technology. You know, I showed you, like, you know, the huge lacks of technology spread. You know, and you know, when the Industrial Revolution came to Europe, it took a long time before it spread everywhere else. But finally, you know, like after 1970s, you know, China and India started industrializing really heavily, and since then it basically kind of is coming back to what it used to be. So, you know, now you can see that China is slowly gaining its previous levels. India is lagging a little bit behind comparatively, you know, to, and like, you know, because of that, you know, countries, what we now, you know, consider developed world is kind of losing its GDP share of the world, which is only a good thing. You know, at least the world is becoming a little bit more balanced than before. You know, and that's why, you know, like you might have heard that China is talking about, you know, a century of humiliation, where like basically like the richer countries force them to do things which they didn't want to do. And you know, that's basically this whole thing since 1900s, you know, till up to 1970s. You know, China was basically on a sideways of the world's GDP, and now it's kind of slowly changing back to a little bit similar take on the issue is, you know, if you look at the three richest countries and at a given point of time, so in the year one, you know, it wasn't actually China which was the richest. It was, you know, if you look at the GDP per person numbers, you know, it was Italy, Egypt, and Greece which are actually the richest per capita, but there was much lesser population, much smaller populations than in China or India at the time, and that's why, like, you know, these countries could have been richer, even though you know, the overall GDP was much smaller. In about year 1000, it was Iran, Iraq, and Turkey. That's where most of the innovations happened at the time. You know, at the time, Europe had, you know, like after collapse of Roman Empire, there wasn't really much of a, like, you know, there was a collapse of GDP as well. You know, of course, like, you know, the like newly dominant Christianity kind of kept like a lot of knowledge happening as well, but it wasn't the major, you know, the major sources of innovations at the time was Iraq, Iran, Turkey. That's where we got our not alphabet, but our numerical system from. For example, most of the math problems were like solved by the, you know, by the academics of the time. And then in 1500s, Italy, Belgium, Netherlands were the richest. mostly because at the time in 1500s, Europe was actually the hotbed of the innovations in agriculture. The same goes in the 1600s. In 1700s, it's basically the same clusters of countries, and then it changes a little bit on then like the period of colonization. Australia, Britain, Belgium. In 1900, New Zealand makes the list, and the United States finally for the very first time. I'm just going to skip through it. In the 1950s, Kuwait, Qatar, and the United Arab Emirates were the richest. Well, that was the time when oil was really expensive, and nowadays it's mostly the tax havens, which are the richest, which is basically one of the syndromes of the globalization as well. This chart. Can you just quickly confirm that you see the next slide?
Yes.
Perfect. This slide basically shows the same thing as before, but again expressed a little bit differently. This is basically, how much of output was created in any given century. It means how many. If I add all these columns together, so if I add all the dark blue columns together, it should give me 100. All right. So it's basically shares of each century on the total of all of the 21st centuries. So you can see that basically almost no GDP was created all the way to 18th century, and then started growing really fast. Of course, 21st century, this was up to, so this is representing only first 10 years of 21st century. But you can see that like basically no GDP was created the whole century, the whole history, and then suddenly like a boom and just like started growing really fast. And the same goes for years lived. You can see that basically people are basically living much longer periods of time than before. Of course, these statistics are, if I look at the first, second, third century, they are influenced heavily on the like child mortality at the time, which kind of skews the statistics down like really substantially. And now to the really important concept, which is called Malthusian trap. I don't know if you're familiar with the concept. It's named after the British political economist Thomas Robert Malthus, who basically suggested that for most of the human history, incomes were largely stagnant because every time there was a major discovery, for example, you find out how to grow more stuff. It was like majority of the innovations before industrial revolutions were always connected to how much crop you could have actually planted and collected and harvested at the end. So so every time there was a major improvement in productivity, and you basically produced more food, that what happened was that people, like the amount of people like increased, and per capita the productivity basically stayed the same or sometimes even worse. And basically, there's kind of like a skeptical point because he basically said that people will never become richer because every time there's going to be more production, then there's going to be more people to eat it, and per capita is going to stay basically constant. It was, he lived in 18th century, so. At the time, of course, it was pre-industrial revolution, or before the industrial revolution actually just started showing its first gains. So at the time, majority of the economy was agriculture. How much stuff you could have grown was basically the GDP. And so the GDP was basically how much crop you could have harvested at the end of every year. And so he noticed that people developed more better techniques to how to farm, and the population of Britain increased, and that was about it. And it showed up not it was kind of ironic because he came up with the idea only at the moment when when Britain finally escaped the thing which later on became known as Malthusian trap, which is the concept which I just described, that countries can't can't increase the GDP per capita because there's just going to be more people to be spread between themselves. But it's a concept which basically plagued a lot of other countries later on, including, and now we can see only now we can see Africa finally escaping, for example, the Malthusian trap, because if you bring like better farming methods, for example, to Africa, and they just start producing more, again, like, it doesn't really make any difference if there's a simultaneous increase in population, and there's a finite amount of land which can be used for. So what at any given country, what you need is, the fertility. That means how many kids families actually have to go down. So the bigger product which is created is not spread out between more people. This chart, which is again kind of a confusing one, I'll try to explain it, basically shows you a historical relationship between output per person and population for different dates in Great Britain. So it will start at 1200s, and you can basically see that there was like a period of relative peace, no major diseases, and you can see that the population was increasing. And at the same time, the output per person, that means GDP per capita, how much food they produced, was basically decreasing all the time. And then in 1310s, there was a period of wars connected with some spreads of diseases, and the population went down substantially. And at the same time, the output per person grew really substantially. And then the cycle repeated once more, all the way to 1650s, when, as I said before, there was a period in Europe when like, the economy went through a really long periods of productivity increases. You guys still hear me, right? Why?
Yes.
Perfect. Yeah, I just realized I scheduled the lesson only till 3 o'clock, so I'm running over a little bit, but I'll get to the end very soon. So around 1600s, Europe had really major increases in productivity in agriculture. And suddenly, the growth in population, which basically went on, you can see that instead of following this path, like, like output decreasing and population increasing, or vice versa, suddenly, population grows. The trend has kind of reversed. The population grew, and at the same time, the output per person grew as well. And that's because the agriculture just basically started producing much more than the population growth actually was at the time. And because of that, finally, even with the growth of population, there were surpluses, which allowed for specialization of labor, which meant more innovation. And then, you got out of 1600s, and this is where the Industrial Revolution started and basically took off. And since then, population grew like substantially, as well as the product per person did. And that was basically the final escape from the Malthusian trap, that the population and output per person could grow at the same time, because the output per person was growing much faster than population. It made it possible. Of course, Britain was the first one to escape. European countries and the United States kind of like quickly followed. And then later on it came, in major of the world, but like some countries basically like escaped the Malthusian trap much later. So, for example, just you see the next slide, right?
Yep, with Malthusian trap description.
Yeah, exactly.
Yep.
Fertility, which in Asia, was really out of hand in 1960s, but like it started after 1960s, it started falling in Latin America in 1970s. It did as well, and the number of children per woman, basically in the scope of one generation came back from 6 to 2 in just one generation. In Africa, there's still kind of like a remnants of Malthusian traps still kind of happening. And it's still the continent which kind of grows substantially in population, and it will do so, even there the fertility is finally coming down like really substantially as well. So Africa still has it's supposed to reach about 2 billion of people in 1945. Give me a second. Yeah, so like even in Africa, basically what we see now is you know that there's a lot of young people, but like, you know, once they stop increasing, they're basically going to be the period when they have a lot of young people which they don't have to feed a lot of young children, and that became known as demographic dividend. So now I'm just going to show you a few charts of, like, you know, what the population charts of, you know, a few countries look like. So in Japan, you see the next slide again.
Yes.
Perfect. So in Japan, you can basically see that you know that there's a population decrease in Japan. So like young people are actually like the smallest group. In Mexico, you know, the stabilization happened basically about 30-40 years ago, and you can see that since then the like amount of kids basically is not increasing, even though the very old generations are pretty small generations. In Nigeria, you know, there's still kind of like an exponential growth. But if I look, again, going to the next slide, if I look at the developments of fertility in Africa, you can see that they are going down really substantially as well. You know, it's in comparison with Asia, which, you know, since 1960s, it basically went down from 6 to, as I said, 2. It's sub-Saharan Africa. Now we are in the stage where like the fertility is going down really substantially. And again, it's really important to stress the, you know, the effect of urbanization, because you know, for example, there's stats from big cities in like Lusaka or in Congo's Kinshasa, you know, that the fertility is already like way behind 4. In Addis Ababa in Ethiopia, it's only 2. Of course, like, you know, the big cities, they are basically like coming, like, you know, the modern economy and basically spread there a little bit faster than everywhere else in Africa, and they're basically leading the way into, you know, how the economy, how people in the economy behave, and how many kids they have. And because of that, again, like, you know, because they have lesser kids, all the productivity increases basically go spread out between small amounts of people, and that's the beginning of the you know, fast GDP growth per capita, which is what we want to see. Is how we measure how rich the country is. The overall GDP doesn't really matter. You want to always see the per capita GDP numbers to be big, and that's how you measure how rich the country actually is. In regards to the global rates, like, you know, maybe sometimes you still hear that people, like, you know, that, like, you know, some people, supposedly smart people, tell you that you know, the world population is still increasing, which is true, and that, like, you know, soon enough it will become unsustainable, which is not true. And also, you know, the population increases they're basically leveling off. This is a chart which is based on UN population estimates, and they basically, you know, you can see that this like exponential growth which we've seen before is kind of leveling off, and the amount, this, you know, this other the other chart which basically shows the like incremental increase of people, you know, how many people basically are added to world's population every year, is decreasing already, and it's going to fasten up. And you know, and this very last chart, which I'm going to show you, basically shows you the relationship between GDP per person and the fertility level. And you can basically see that, you know, of course, poorer countries, they are basically the ones who didn't escape the Malthusian trap yet. But as you increase the GDP per capita, the fertility goes down, then it goes actually under, but like eventually just going to stabilize at 2.1, which is considered replacement level. Basically, if you have a 2.1 kids per woman, it basically means that there is going to, like, the population is going to stay stable. It's mostly because like people quite often just, that it has to like include people who are not going to make it to the age of having kids. That's why it's not 2, it's 2.1. So, the very rich countries basically have just perfect replacement level and a replacement level, number of kids. And that's why like majority of these countries, if you don't include migration, basically keep their population pretty much stable. It's one of the like unexplained mysteries of demographics of like why is it actually happening. But there's a good chance that like after a while the population of the world will basically stabilize at around just under 10 billion. And in regards of like if the planet can produce so much food to actually feed the population, I think the answer now is pretty much clear that it will, mostly because in majority of the rich countries you actually don't even need all the land which is right now being used for agriculture, mostly because the agriculture still increases its productivity like extremely fast. It doesn't really show that much because it doesn't really show, you don't really see in GDP numbers the contribution of agriculture as much because agriculture is comparatively small portion of GDP. But and it's mostly because it just became so cheap, like because agriculture became so productive, it kind of became too cheap to even like create too much product. But in a majority of the rich countries, you can see that the agriculture is so productive that the farmers basically can't, even sell the cheap stuff in such quantities as they are able to produce. And then that's why the arable land is actually going down in majority of countries, including most of Europe and United States. And in regards to developing countries, well, they are still not using majority of the innovations which can be used in agriculture to actually produce more food, and they surely will. So if the population stabilizes around 10 billion, there is no question if the world is going to be able to feed itself. Most likely the biggest question on next century or this century, later on this century, will be how to feed ourselves better. Not the question is not going to be if we're going to feed all people which live in the world. And that's the end of the lecture. Thank you very much for your attention. I hope it made a little bit of sense. I'm still getting used to this online teaching, and yeah, so I thank you once more for the attention. Any questions at the end?
No, but thank you for the lecture.
Thank you very much.
All right. So in that case, have a good time. We'll have another lecture exactly at the same time next week. So I hope you all come. If you can, just drop me an email and it's fine. Anyway, I'll just put the lecture again on YouTube so you can watch it later on. All right. Thank you very much. See you next week.
Thank you. Take care. Bye-bye.
Bye.